Atom. Now, what is an atom? The structure of atom consists of the nucleus. It is in the middle of the atom. It contains protons and neutrons. It has a positive charge because of the protons. Almost the whole mass of the atom is concentrated in the nucleus. Electron. It moves around the nucleus. These are negatively charged particles. They are tiny but cover a lot of space. The volume their orbit occupy determines how big the atom is. They have virtually no mass. They occupy shells around the nucleus. These shells explain the whole of the chemistry. Now, the particle proton has a mass of 1 and the charge of +1. The particle neutron has a mass of 1 and the charge of 0. The particle electron has a mass of 1 upon 2000 and the charge of -1. Now, electron shell rules. Electron always occupies shells or energy level. The lowest energy level are always filled first. Only a certain amount of electrons are allowed in each shell. That means first shell 2, second shell 8, third shell 8. The atoms are happier when they have full electrons filled. In the most atom, the outer shell is not full, and this makes the atom wants to react. Now, what is atomic number and mass number? The mass number is the total number of protons and neutrons, and the atomic number is the number of protons. The atomic number tells you how many protons are there. This also tells you how many electrons are there. To get the number of neutrons, subtract the atomic number from the mass number. The mass number is always the bigger number. The mass number is always roughly double of the atomic number, which means that there's about the same number of protons as same number of neutrons. How do we denote? For example, if we have a sodium atom over here, so 23 is the atomic mass number, which is also called as nucleon number, denoted by A, whereas 11 is the atomic number, which is also called as proton number. Now, over here in this equation, uranium 238 92 forms thorium 234 90 plus helium 4 and 2. This is a balanced equation given in the form of atomic mass number and atomic number. Now, what are isotopes? Different forms of the same element. Isotopes have same atomic number but different mass number. Just like carbon has got two isotopes, carbon 12 and carbon 13. Now, in the nucleus, this one has 6 proton and 6 neutron, and in the nucleus, carbon 13 has 6 proton and 7 neutrons. Okay. Now, isotopes are atoms with same number of protons but different number of neutrons. Next, isotopes. Most elements have different isotopes, but they're usually only one or two stable ones. The other isotopes tend to be radioactive, which means that they can decay and give out any other element out of radiation. This is where all radioactivity comes from. Unstable radioactive isotope undergoing a nuclear decay and forming and spitting out the high energy particle. Atomic structure, 1991, Rutherford model. Now, here we understand the scattering of the particle, which helps us understand the atomic structure in better detail. So what Rutherford did, Rutherford allowed a beam of alpha particle to pass through a gold foil, and he figured out how the particle will react or how the particle will bounce back. Most of the alpha particle passed straight through the gold atom, but a very few bounce off at a larger angle. Conclusion is that atom is largely empty, but positive charges and most mass is concentrated in the tiny nucleus which is at the center. Now, what do you mean by nuclear fission and nuclear fusion? Fission means splitting of an atom. So, when a neutron comes in contact with uranium, it splits into two different particles. So, this is called as fission. Now, when it does, it releases a long and big amount of energy. So, that is how fission takes place. Whereas fusion is where two hydrogen nuclei combine together to form helium. Now, fusion is very difficult to achieve. The gas must be very hot that at any temperature to overcome the natural repulsion of the fast moving nucleus. Now, fusion occurs naturally on the sun, where four hydrogen nuclei fuse to form helium. Background radiation. When we talk about radiation, there's always some amount of radiation around us at all the time because of radioactive material in the environment. And this kind of radiation is called as background radiation, which comes from the various sources. Now, what is this instrument which we are going to study? Now, this is called as Gregor-Muller tube or counter tube. When a radioactive particle enters in the tube, it ionizes the gas inside and triggers an electrical discharge, which makes a clicking sound. So that is why we understand whether we have received the radioactivity or not. Now it comes from the various sources such as unstable isotope around us in air, food, building material, and in rocks under feet. Radiation also comes from space, which is called as cosmic radiation. Now, these are the various parameters or values through which radiation comes from. It also comes from which the planes which are flying in the air, some underground radiation, some in mining areas. Now, the major three types of radiations are alpha particle, beta particle, and gamma particle. Now, what is an alpha particle? A helium nucleus consisting of two proton and two neutron. The relative charge of alpha particle is +2. It has a very high mass compared with beta particle. The speed is 0.1 times the speed of light. It is very strong ionizing effect. It is not very penetrating. It can be stopped by paper or skin of few centimeters of air. It is deflected by magnetic and electric field both. Next is beta particle. Each beta particle is basically an electron. It has got a relative charge of -1, low mass compared with alpha particle. Speed is 0.9 times the speed of light. Weak ionizing effect. Penetrating but as compared to gamma less. It can be stopped by few millimeters of aluminium metal. It is also deflected by magnetic field and electric field. Next is gamma particle. Basically, it is not a particle. These are waves. These are part of electromagnetic spectrum. It has got no charge. It has got no mass. It travels at the speed of light. It is a very weak ionizing agent, very strong penetrating material. Intensity reduces only by thick lead or concrete. It is not deflected by magnetic field or electric field. When we consider ionizing effect, so alpha is the maximum, then comes beta, and then comes gamma. When we consider the penetrating effect, the gamma is the maximum, then comes beta, and then comes alpha. Now, how do they get deflected on a electric field? Alpha particle positively charged, so it is deflected in the direction of the negative terminal. Beta particle negatively charged, so it gets deflected in the direction of the positive terminal. Gamma particle no charge, so it does not get deflected. Radioactive decay is a random event, and the unstable nuclei in some material breaks or disintegrates. It is impossible to predict exactly which nuclei will decay. This disintegration of the nuclei is called as radioactive decay. The three types of radiation we have application. The first application is tracers in the medicine. Then we have tracers in industry. Then we have sterilization of food and surgical instruments. So we use these types of radiation and find out various tracers and sterilization. Now, thickness control. With the help of radiation, we can also do automated thickness control of industries. Then we have radiotherapy. Radiotherapy is given to kill the cancer cells. Then carbon dating. Carbon dating is used to find out the age of the fossil. Then generating power. So uranium is one of the source which is used to create energy and generate power. Half-life. What is half-life? Half-life is the time taken for half of the radioactive atom now present to decay. Okay, so that is called as half-life. Some types of nucleus are more unstable than others and decay at a faster rate. Radioactive decay is a random event. The unstable nuclei in some material will break to disintegrate. It is impossible to predict which nuclei will decay. This disintegration of the nuclei is called as radioactive decay. Now, over here we have some examples of half-life. So, nuclei has a half-life of 10 days. So, in first half-life, it becomes 32 from 64. In next 10 days, it becomes exactly half of 32, which is 16. In next 10 days, it becomes exactly half of 16, that is 8. So, here we have the half-life of a nuclei given. If it is plotted on the graph, in this way, we can plot the half-life of the given nuclei with the help of a radioactive decay curve.